on this computer. All right, it says that the cross section of an object has the shape of a quarter circle of radius r, adjoining a rectangle with x. Yes. Oh, got it. R adjoining a rectangle with x and height r. The perimeter and area of the cross section are P and A respectively. Express each of P and A in terms of R and X, and hence show that A equals half P times R minus R squared. So let's do it. So the perimeter, how would you do your perimeter here? Talk to me. Okay, so let's do the perimeter. This is R plus X plus R plus X plus. All right. So what's the circumference of a circle? That's area. 2 pi R. But this is not a full circle. This is a quarter of a circle. So we're going to divide it by 4. So we're going to end up with pi R over 2. So this here expresses your perimeter. Let's just make it look prettier. That's going to be 2R plus 2X plus pi R divided by 2. Agree or disagree? That's how we get perimeter? Yay or nay? Yay. Okay. So now let's do our area. I'm gonna erase all this stuff I wrote here. Now it's fluid. So it must have been running out of memory, or who knows, the processor must have been overheating. That's probably it. The processor could have been overheating. So the area here, what's the area of this section right here? What would that be? What will be the area of that rectangle right there? Yes, R times X. Does everybody agree that that's the area? Okay. Let me go ahead. I'm erasing. So this area here is R times X. Now, how do we figure out this area here? What's the full area of a circle? Pi R to the, so a quarter of a circle, you would do what? Divided by? You divide it by 4, or you multiply by 1/4, or you multiply by 0.25. Yeah, I remember you said that. I said to myself, she's right. However, it's more elegant to say pi R squared divided by 4. Don't you think that's more elegant? So therefore, the total area must be pi R squared divided by 4 plus R times X. But is that the answer we want? No, they want it to look like this. So guess what you're going to have to do? You're going to have to figure out a way to express X in terms of R. So that means you have to express X in terms of R. That is possible, but it's not just R, it's R and P, because notice that if I look at this here, if I take P here, P equals 2R plus 2X plus pi R divided by 2. I'm going to have to rearrange this so that the X, so I might say this, 2X equals to P minus 2R minus pi R divided by 2. Do you guys see what I did there? Yes or no? Yay or nay? And now look what I'm gonna do here. You see that? And now look, I'm gonna just clean it up a little bit. I think I'm missing. No, it's good. It is that. Okay, good. So now that's X. And guess what do you think I'm gonna put that X in? I'm gonna put this X where? Right there. And why am I doing that? Let's see, because we want to write out the area a certain way. So now let's go ahead and write area. Oh, no, I don't like that color. So let's write area equals to pi r squared divided by 4 plus r times pi divided by 2 minus r minus pi r divided by 4. So that's pi r squared divided by 4 plus PR divided by 2 minus r squared minus pi r squared divided by, and I think that's a 4. I'm not sure though. I wrote such an ugly 4. Let me fix it. It is. I don't have to put the parentheses because I distributed. And what happens? Look what happens, wonderful people. Yes, you simplify, but look what happened. Look at this guy. They're gone. And look what you're left with. Half PR minus R squared. And guess who does that look like? It looks like that guy. Great, let me zoom in. It looks like that. And that's what we wanted, didn't we? Look. And hence show that. And we did part A. Does that make sense, wonderful people? Yay or nay? It is. Seems like a lot of work. It's just practicing your manipulation. That's all it is. I'm gonna eat tacos today when I get home.
You text your wife.
I'm gonna saca picadillo. So let me tell my wife to saca picadillo. Then she's gonna get angry because she has to make it for me. But if she doesn't make it for me, I'll have my mother make it for me. So yep. But my mother's getting old, so her food's starting to lack a little bit. Let me tell my wait. Saca el picadillo.
Por favor.
Oh, please. All right, guys. But we're not done with this question. We're almost done with class, but we're not done with this question. So let's take a look at part B. It says here, taking the perimeter P of the cross section as fixed. So that means we're taking P to be not a variable that we know P. So P is a constant. Find X in terms of R for the case when the area of the cross section is a maximum, and show that for this value of X, A is a maximum and not a minimum. All right, so let's try it again. So taking the perimeter, okay. Find X in terms of R, okay, fine, okay. When the area A of the cross section is a maximum, and show that for this value of X, A is a maximum and not a minimum. All right, so here's what I'm gonna do, because I'm gonna go ahead and look at this here, and I gotta remind myself that X is this, okay? But I'm gonna find dA, dr first. And so this is just going to be half P minus 2R. And I'm going to, right? I'm going to take my derivative with respect to R. I want to find out when the area is maximized. And then once the area is maximized, let's play around with it. Let's just play around with it. So dA dr is equal to 0 when there's a stationary point. So 0 equals half P minus 2R. Therefore, 2R must equal to half P. So R must equal to a quarter of the perimeter. Now this is important. All right. A quarter of the perimeter. So I can substitute this in here and I can figure out X. But then I have to show whether that's a max or a min. Now, the perimeter has to be a positive number. All right. So let's play around with it. Like, let's just pretend P is 1. So if P is 1, if I substitute this in here, you have half P minus 2 1/4 P. And that's the problem right there. But let's see what it comes out to. dA dr. Half minus half. Of course, it comes out to 0. That's if P is 1. So that's R equals to 1. And then you test both sides. So let's do that. So we have, if P is 1, R is 1/4. So now we can test both sides. Where to?
Like a little bit more there.
Right here? Okay. So let's be careful here because P does not vary. P does not vary. So we want to show it's a max or a min. And so this is actually R. Now, my main issue here is when we go back to this here, and let's say I can't pick 0 for R because then it doesn't exist. But I can pick, for instance, 1/8. I can pick R 1/8. I can pick R 1. Okay. But P is always going to be 1 because I fixed it. I fixed it. So now I'm going to pick R1. Put it here. So that's half minus half. That's not good. Oh, no. Sorry. There you go. Half minus 2. 2 times 1. Half minus 2 is what? Is it positive or negative? Negative. So over here we have this. So it goes down. And so now let's pick 1/8. So P is 1, but then now I pick 1/8 here. What's half minus a quarter? Half minus a quarter is positive. So in that case, 1/2 P, or this here, 1/4 P, is always going to be a maximum. So now you can go ahead and replace it over here. 1/4, sorry, P divided by 2 minus 1/4 P minus pi R divided by 4. Wait, what's R? R is 1/4 P. So you get X equals P divided by 2 minus 1/4 P minus pi divided by 16P. So X equals pi divided by 16P plus 1/4 P. So that is supposed to be X But they want, so when the area A of the cross section maximum, and show that for X, A is a maximum and not a minimum. So now we can go ahead and substitute this X into A, and are we almost up with time? All right, so guys, the problem is almost done, but go ahead and stop this recording and stop this share.